evening, students. Welcome to one more session of your WOC. This is your Vani ma'am back again with day 7 200 expected questions. So as you all know, students, 200 expected question series is going on in my channel. 200 expected MCQs also is going on in Unacademy CBSE grade 11 and 12. I am posting the link in the community tab. Remember students, MCQ weightage is more this time. So as I promised, 200 plus 200, 400 questions would be done, which would be the most expected and important. I'm happy some of the students are joining me, but I expect all the students to join me so that knowledge is given to you for free, isn't it, no students? So please watch 200 expected questions in my channel too, and the link which I am sharing in the community tab, please watch that also. The reason, students, our targets are high. We wanted to score that 70 out of 70, and some students wanted to get through the exam. Some students who have planned to get out of 70, 45, you also would have dreamt of getting more than 55. Yes or no, students? So please watch 200 questions in my channel. 200 questions which are going on in Unacademy CBSE grade 11 and 12 every day between 8 p.m. to 9 p.m. It has started. Today we are almost on the day 5. It's going to go for till almost 12 days. Please watch it, students, and take a notebook. Keep noting it, because in MCQ series I'm explaining each and every question with a lot of patience. Right, let us start off, students. Okay, so basically day 7th, your 200 expected question. Let us see question number 13. Question number 1 to 12 are kept in the playlist. Please check it and note it. Okay, here this is basically a coordination compound chapter. So normally coordination compound chapter, students, compulsory there is a question of this sort. Compulsory, because in coordination chapter we either have Werner's theory, we either have isomerism, which is deleted this year, right? But then too, I'll just give you the question, and the leftover is CFT, or the leftover is your valence bond theory, isn't it? So please concentrate on this question, very important. If possible, please share it to your friends and more students, right? So here they given for the complex, there is one complex given to me. Write the hybridization, write the magnetic character, and write the spin of the complex. Okay, so basically 3 things I have to find out. Okay, this complex, once it is given to you, note this complex, students. So solution is given to me. Step number 1, noting the complex which is given to me. Now let us go step by step. Step number 2 is to see whether the ligand, this is the metal atom, this is the ligand. See whether the ligand is weak field ligand, strong field ligand or not. Important. We very well know if it is strong field ligand, pairing happens, because if pairing happens, hybridization is going to change, correct? Now if weak field ligand is there, no pairing happens. Check. Here whatever water is there, basically it's neutral. At the same time, water is H2O is a weak field ligand. Weak field ligand, correct, my students? Okay, if it is a weak field ligand, what is the concept? Does pairing occur? No. So no pairing occurs. So no, you have to write all this in the exam. No pairing occurs. This is also okay. Over. Now this is my step noting is 1. This is my step 1. I'll write like this, step 1. Now I'm going to step 2. Let us see, students. Step 2 is what I'm going to write. Now in step 2, I have to write the ground electronic configuration of this metal atom. They normally in the exam atomic number will be given to you. You need to write the electronic configuration. So iron for Fe metal, the atomic number is 26. Ground state configuration, ground state electronic configuration is argon 3D, yes students, 3D6 4s2. This is the ground state configuration. Now in this ground state, how many are there? 3D, 1 2 3 4, 1 2 3 4 5, 4s 4p, correct, no? 4s 4p 3D. How many electrons are there, students? 6. 1 2 3 4 5, okay, and 6 1 electron. In 4s 2 electrons are there. Now they said, first, this is my step 2. Now step 3, what should I do? I have to check what is the oxidation state of this. Now I said water is neutral in nature. When water is neutral, what will happen, students? Here Fe H2O taken 6 times plus 3. X is how much now? X is, this is 0. This is only 0 because it is oxidation. It's a neutral ligand, no charge on that. So just like your ammonia. So iron would be how much? Plus 3. So X would be plus 3 because there's no value, there's no charge for water. So plus 3. What will you do? You are going to take out 3 electrons from the orbitals. So 3 electrons from where will you take out, students? 1, 2, 3. Understand? 1, 2 and 3. So now this is your ground state. Now excited state configuration would be what, students? Because it is Fe plus 3. It is Fe plus 3. Correct, no? Fe plus 3, argon configuration. This will become 3d5 4s0. Correct. Now write it. What you will get? 3d5. 1, 2, 3, 4. 4s is empty. 4p is also there. 1, 2, 3, 4, 5. Over, students? Okay, done. I think you're able to see the board, right? Let me once check whether you're able to see the board, or I'll move the board a little bit down. Now let us start off. So what did we do? We got 3d5 4s0. Now students, I'm writing it here. If you don't mind, I think it's okay, or I'll rub the whole thing. Okay, note everything. I'll rub everything. I'll note. Okay, let me rub because I need space. Right, students? So I'm taking the whole thing again. Okay, I'm taking the whole thing and I'm writing it for you all. So what actually is this now? Where are we now? Fe plus 3 is the excited state. We are at argon. It's nothing but 3d5 4s0. Now you have how many water molecules, students? You have basically 6 water molecules which are there. These 6 ligands have to fill the space. 6 ligands, correct? No? Write the configuration 3d5. Okay, little bit longer. 3d 1, 2, 3, 4. This one 4s0. Right, then comes 4p, 3 orbitals, then comes 4d also. 4d 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay, I wrote extra 1, 3, 5. So this is 3d 5. This is 4s0. Don't write here. It is 4s. Then this is 4p. This is 4d. It is d orbitals, no iron. Okay. So now check, students. Fill 1, 2, 3, 4, 5 over. How many ligands should come and occupy? 6. So because it is a weak field ligand, this part, and this part will occupy. Now how many? 6 ligands. 1 for water, 2 for water, 3, 4, 5, 6. Because opposite spin, no? So you will fill both this one. This is basically like this. So instead of that, I put cross. Okay. Now, how many are there, students? Yeah. Check here. What is the hybridization? This is the hybridization. So I am writing hybridization here. Hybridization observed is what? sp3d2. sp3d2. Understood, students? Okay. Now, what is the next one they said? Spin magnetic moment. You have to calculate in Bohr magnetons. So basically spin magnetic moment, what is there? So the formula is students, nothing, root n into n plus 2. What is n? N is a number of unpaired electrons, so which is equal to root 5 into 5 plus 2. When you solve, you will get an answer around 5.9 Bohr magneton. Simple. Yes, students, nothing, any confusion? No. Hybridization I got, spin magnetic moment I got. Now tell me magnetic property, paramagnetic or diamagnetic, all are unpaired electrons, all are unpaired. So the magnetic behavior of this is nothing but it is paramagnetic in nature because all are unpaired electrons. So easy question, isn't it? First step, step number 2, step number 3, step number 4, step number 5. Now let us come back and see one more expected question. Now let us see the part B of your 13th question, students. In the same chapter they have given you a basic choice, right? So this is a choice question. Now check, students. Draw crystal field splitting for octahedral complexes, right? So basically crystal, I told you, you have Werner's theory concept 1. Isomerism is deleted. Either they may ask you the concept of hybridization or crystal field theory. In crystal field theory, there are varieties of questions asked, like they may ask you based on pairing energy, or they may ask you to draw like this, or they may ask you to give the nomenclature. Let's see. So here, draw crystal field CFT for octahedral complexes. So octahedral complex, as you all know, students, I am expecting you all would have watched the coordination compounds chapter. Here we are doing just the concept understanding and what is expected. No, right? So here, first thing, octahedral complex means in an octahedral splitting, when we see octahedral splitting, students, how is the d orbitals, how is it divided? Basically, in octahedral, when we take d orbitals 1, 2, 3, 4, 5, these three are called T2G sets, correct? These two are called EG sets. T2G is called triplet degenerate set. EG is called doublet degenerate set. How is the splitting in octahedral, students? First, you have to draw. They ask you to draw, no? So, draw all the 5 degenerate orbitals. All of the same energy. So, all are degenerate, equal or the same energy. Now when a ligand approaches, it goes to this higher state. Let me rub this, I need the board. It will go to the higher state. So all again in the degenerate state only. 1, 2, 3, 4, 5. Higher state, little bit, because there is no place, I drew it little bit there only. Now further in octahedral, it splits into two. Basically, first, as I said, in the state, ground state would be your T2G set. So T2G set, that is nothing but dx square y square. Okay, so sorry, your T2G x y y z zx. In the top you have your EG set, x square y square z square. Between these two, so this is your EG set, right, like this, T2G set, EG set. From here till here the total would be 10 dq, correct, no? 10 dq. Now this center is called Barry center. Now when we see, I have not drawn it to the scale, just I have drawn it for your concept. If you want to learn the concept, go to the coordination compound chapter and watch the whole video, you will understand. From here till here is minus 0.4. From here till here, this part, total is 10, I told, no? Let me write this total 10 here. From here till here is 10 dq. So from here till here is minus 0.4. This is plus 0.6. Minus 0.4 plus 0.6 is total 10 dq. This is called the splitting. When you take tetrahedral, it will be the reverse. T2G will go up, EG will come down. So they ask you to draw crystal field splitting. This is the splitting. They are going to check whether you have drawn all. If you still want to write, want to be specific, write here dxy, dyz, dz square, dx square y square, dxy, yz, zx, dzx, x square y square, dz square, xy, yz, zx, x square y square, square. Write all the degenerate, show them the splitting. Easy, students? Easy? I think it's clear for you all. Right. Let me check whether it is clear or visible or not. Right, now let us see, students. So basically this is the next question of your 13th part. What is that? On the basis of CFT, write electronic configuration of D4 ion if crystal field stabilization energy is less than pairing energy. Okay, so nothing to get confused, students. They have given you this ion. Take this ion D4. Basically, d orbital means it has 5 degenerate orbitals. Just now we have seen 3 are called T2G, 2 are called EG. Now 4 are there, isn't it? Now here this is the concept. They said crystal field stabilization energy is less than the pairing energy, means it will not pair, it will go to the next state, right? That means it has T2G set, it has EG set. If this is less than the pairing energy, means the electrons will be distributed T2G down like this, EG up. The electron after filling here, it goes to the higher state. That is what is less. If it is more, then you should not draw this, it fills here only, remember that. Now check, students. 4, no, write 3 here, write 1 here. That's all. That is the representation. Nothing else. Easy, no? You have to check this part, less or more. If it is less, fine. If it is more than this, it will start pairing here only. Got it? Okay, this is the question. Next, students, IUPAC name of the following. So basically this is nothing, most of the students get confused. This is potassium. Start from here. Hexacyano. I did rules of coordination compound, what to remember, how to name. Please watch the video, right? Hexacyano ferrate, because we remember for negative ligands we use cyano. For metal atoms we use ferrate or 8. Remember that. So potassium, hexacyano, ferrate, 3 complex. So ma'am, how did you get this? So I told you, no, please check with the oxidation numbers, you will automatically get this. Now let us come and see question number 14 for the day. Right, now let us come back and see the 14th question for the day. Again, it has part A. Let us see this. So here they have given us phenol, they have given us carbon tetrachloride, they have given us sodium hydroxide. Remember, students, you have studied a reaction that is nothing but Riemann-Tiemann reaction. In Riemann-Tiemann reaction, chloroform plus potassium hydroxide, there you will be getting salicylaldehyde, correct? Here, when you are treating with carbon tetrachloride and sodium hydroxide, the product formed is a salicylic acid. Remember, salicylic acid. This is called salicylic acid, or basically, you know, students, here confusion, students were getting confused, ma'am. Riemann-Tiemann reaction, whether it is this one or not, nothing to get confused. So basically this is the compound, just check. Now next thing. Now the next question, this is the question from ethers. Remember, whenever you are treating ethers with HI, there is one logic which you should remember. Simple. Whenever you have a bulkier groups like this, tertiary if you have, remember, if you have a tertiary group, the tertiary group goes with the halogen, and the group smaller than that, remember, it comes out with OH. So what product do I get? CH3, okay, OH, this one, and the leftover is your tertiary alkyl iodide, tertiary alkyl iodide. That's all. Remember, students, alcohol and iodide. If it is primary, that rule would change. I've explained that in the video also. Please watch it. Now next comes COC2H5. Okay, so basically what is this, students? What is this? This is a nitrating mixture. Correct me, students? Nitrating mixture is going to give me basically two important, or first of all, it is an electrophilic substitution reactions. I accepted. This electrophilic substitution reactions is going to add electrophile NO2 plus. This electrophile is going to give me two different products. What are they? Check, students. This can be written like this also, no problem. It is here, no problem, right? Here, so C2H5. What is this? This is going to generate an electrophile, and this forms two products. One product is OC2H5 NO2 plus, ortho product I get, this is minor, and I'll be getting one more product, that's nothing but OC2H5. Let me write little bit down. OC2H5, and you get para product. This is a major product. Got it, students? Easy, right? So this is one variety of question which is asked. So let me see one more question for you all. Now let us see part B of your 14th question. Right, students, so basically as you have seen, I would have given almost 10 questions today in both the questions together. Right, so identify ABC. Identification questions are very important for your 12th board, remember that. Okay, now this is your phenol. I have to identify A, I have to identify B, I have to identify C. What is important? You have to see what is the reagent present on the arrow, because reagent does its work here. What do they give me? Bromine in the presence of carbon disulfide. There are two reactions of phenol, one with bromine water, one with bromine in carbon disulfide. If it is bromine water, I get 2,4,6 tribromo-phenol, but here it is bromine in the presence of carbon disulfide. So what do you get? You get two different products. One is phenol, one ortho product, one more phenol with para. So remember, students, this is major, this is minor. So what is one more thing I said just now? Bromine water, correct? No, remember, phenol plus bromine water, you will be getting a product 2, 4, 6. All the three groups are combined with bromine and you get this product. Now when I take the B part, now check here, what type of name reaction is this? Kolb's reaction, correct? Kolb's reaction, Riemann-Tiemann reaction, the final product is salicylaldehyde. In Kolb's reaction, it is salicylic acid, simple. So when you see carbon dioxide and NaOH, nothing to do, you are going to prepare salicylic acid. That's all. This is your Kolb's reaction, prepare salicylic acid. Last, this is your acetic acid. Now check, students, phenol plus acetic acid, nothing to do. Check here, you are, see here, your OH of this and your H of this comes out as water. That means water is out. What is left out, students? Take this group, attach here, write down. Write this benzene ring, oxygen is there only, CO is here, CH3 is here. Simple, nothing I did. If you don't know the names also, nothing to worry. Write the product, you will get marks, because here important thing is product formation. Got it, students? Thank you so much for joining me today. I'm expecting students to please share and share and share. More you share, the students who can't afford can watch it. Correct, no, students? Knowledge has to be shared always. Thank you so much. Signing off, Vani ma'am here. We'll meet you again day after tomorrow with more and more questions. Noted, student? Keep noting in your book. I'm doing almost in each question again subparts. Thank you so much. Please watch the complete video.